Graham walks 8 blocks from his home to the library. He walks 4 blocks to the east and 4 blocks south. So here is his home. 1, 2, 3, 4 blocks to the east. 1, 2, 3, 4 blocks to the south is the library. But if we set this up, that is not the only way he could go. There we go. Now can I erase it? Perfect. We're going to assume that Graham is a smart child, that he doesn't get lost on the way to the library, that when he decides to go to the library, this is not a route that he takes. Oh, where's the library? I'm looking. Library, where are you? That is not how Graham goes to the library. He will always go closer to the library each time. So what's one possibility? He's at home. Which way is he going to go? South. He's going to go south. Then? South. South again? This is one possibility. Okay? So you go, the bad strategy to figure out how many there are, you can go, okay, that's 1. Tiki mark. Erase it, memorize it. I've done that one already. What's another one? There's another one. How long is this going to take us to count them all? Are you going to remember which ones you've counted and which ones you've missed? Okay. How is this a Mississippi question? There's multiple souths and multiple easts. Each time he goes there, he has to go south 4 times and east 4 times. And each unique rearrangement of these letters is a unique path. The first one that we did, which was south, south, east, south, east, south, east, east, is represented by south, south, east, south, east, south, east, east. Si. Si? Okay. Do you understand? Si. Okay. So, if you have to go 4 S's and 4 E's and you want to count all the different arrangements, well, normally if they were different letters, that would be 8 factorial. But we have identical objects. So you have to divide by 4 factorial, and you will get the total number of ways that he can go from home to the library. Now, another strategy for figuring this out is to count them 1 block at a time. How many ways can he get to this intersection? Right? If he's always going closer, does it make sense that there's only 1 way to get to that intersection? How many ways can he get to this intersection? 1 way. Right? There's no other pathways other than straight there. And same for this one and this one, 1 and 1, and same thing going down. Does that make sense that these are the only way that he can get to those dots is 1 way if he's not backtracking? How many ways can he get to this dot? 2 ways, because he could go here or here. 2 ways. How many ways can he get to this dot? 3. Right? This way, 1, 2, 3. How many ways to this one? 3. See if you can see a pattern. How many ways to this one? 4. No. 4. Good. How about this one? 6. Nice. This one? 5. 10. 5. 15. 20. 15, 35, 35, 70. And sure enough, if you multiply that out on your calculator, you get 70. Okay? How did you figure out this was 10? Because you take the paths, if you could get here 6 ways and here 4 ways, you can get there 10 ways through those 6 paths or through those 4 paths, making 10 total ways. Okay? Sometimes they have these questions where they put like a lake in between. So then you have to solve it this way. Anyways, the questions you can do with this one are number 12. Later on, we'll also introduce other interesting things like Susie lives here, and when Graham walks to the library, he always walks by Susie's house.